Hello everyone, welcome to Shiwam's classes. In today's lecture, we are going to discuss problem number 6 to 10 from the chapter 3rd, and the exercise number is 3.2. So, in these problems, we are going to discuss finding out the values of uh, trigonometric functions at various given values of angles, which could be in degrees or in radian. So, before proceeding with the solution, let's try to understand some of the basic concepts behind how to solve these problems. Alright, so let's first draw the coordinate axis so that we understand how the angles work. So when you look at the coordinate axis, you know from here to here we have value of theta from 0 to 90 degree or 0 to pi by 2. So from here to this side will be moving in the positive direction, and our value of theta would be pi by 2 or 90 degree. When we go from here to here, then our values would be pi or 180 degree. When we go from here to here, then the value will be 3 pi by 2 or 270 degree. And finally from here to here, it will be 360 degree or 2 pi. Similarly, you can go in the other direction as well and try to get the values. Like here to here, it will be minus 90 degree. Then from up to here, it will be minus 180 degree. And then from here to here, it will be minus 270 degrees. And from this side, from here to here, it will be minus 360 degree. So in this direction the angles are negative. So you know, right, you can actually look at this relation as well. Pi by 2 equals to 90 degree, then pi equals to 180 degree, and then 3 pi by 2 is equals to 270 degree, and then similarly your 2 pi is 180 degree. So if you put it plus and minus, it will be also plus and minus, 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 and plus and minus. Alright. So now you can either go in one direction or another. The third thing which you need to know here is, again I'm just trying to draw another coordinate axis, that for sine and cos, sine theta and cos theta, the values repeat. What I mean is, the values repeat is like whether you are here or you are taking a full circle and coming here. So whether you are here or you are taking a full circle and coming here, the values will again start rotating. So we know that the values of sine theta and cos theta would be repeating. In some other lecture, I will try to explain you how the graphs of sine theta and cos theta would be. But you know that at every 2 pi the values would be repeating. And then for tan theta and cot theta, every pi the values will be repeating, right? So we have to make use of these relation and try to see that, right? So we'll take the first problem. This is sine of 765 degree. This is sine of 765 degree. Now we can write this as sine of 360 degree into 2 plus, so 360 degree into 2 will be 720 plus 45 degree. Why did we do that? Because as we discussed, sine theta would be repeating after every 360 degree, right? So we can come back to the same place when we take 2 rotation. So after 2 rotation, we will be back to the same place, and then we can go in this direction with 45 degree. So now what we get here is sine, this will give me sine 45 degree. Okay, so this will reduce to sine 45 degree, and you know the sine 45 degrees value is 1 by root 2. So this is the 6th problem. Now let's look at the 7th problem. My 7th problem talks about cosec of minus 1410 degree. Cosec of minus 1410 degrees. So cosec of minus 1410 degree, again can we can write it as in two ways. What we can do is, uh, first is, let's add something near to this. So for example, 360 degree into 2 would be 720 degree, and 720 degrees multiple of 2 would be, this will be my 1440 degrees, right? So I can write this as cosec of, say, I'm just adding this 4 4 into 360 degree, and then when I do this, this will become 1440 degree, right? I'm just adding this to 1410 degree. So this will give me what? This will give me nothing but cosec of 30 degree, right? Why did I add this? Because we know that after every 360 degree I will be back to the same location. That is why I rotated it by 4 times by 360 degree to come back to the same place. So what I mean is, see, if it is theta this way, right? This is my negative theta. What I can do is, if I add 360 degree to it, what will happen to it is that it will, if I add 360 degree to it, is what? I am adding this 360 degree to it, right? This is nothing but, this is 360 degree minus theta. I can as well, I can say that, right? Minus 3 theta is equals to nothing but 360 degree minus theta. And this will keep happening for as many times I will keep rotating, right? So this is why I did this thing. Now cosec 30 degree is what? 1 upon sin 30 degree. 1 upon sin 30 degree is nothing but 1 upon, if you remember cosec 30 degree directly, that is fine. If you don't, then you can do this as well. This will be 2, right? Now coming to the third problem, which is 8. This is tan of 19 pi by 3. Tan of 19 pi by 3. Tan of 19 pi by 3. Can I write it as like tan of 6 pi plus pi by 3? Because 6 3s are 18 pi plus pi by 3. So this is what I did. And this is again, every pi is 360 degree, right? You know that every pi would be, 2 pi would be 360 degree. So this will be nothing but tan of pi by 3, and we know that tan of pi by 3 would be nothing but root 3. So this would be the answer, right? Now coming to the next problem. My next problem says minus of sine of minus 11 pi by 3, right? Sine of minus 11 pi by 3. Sine of minus 11 pi by 3. Again, can I add 4 pi to it? 4 pi minus 11 pi by 3, which is nothing but, I have just added 2 pi. What I have done is, I have rotated 1 and I have rotated twice. Once you do that, you will be reduced with sine of 12 pi minus 11 pi, 12 pi minus 11 pi by 3, which is nothing but sine of pi by 3, which will be nothing but root 3 by 2, right? Now coming to the last problem. My last problem is cot of minus 15 pi by 4. Cot of minus 15 pi by 4 would be what? Again, I'll have to add 4 pi over here. 4 pi minus 15 pi by 4, which is nothing but cot of pi by 4, which is nothing but 1, right? So in all these problems, you see what I have done. I have added multiple of 2 pi. Every time I have added multiple of 2 pi. You could have also worked on these problems, like for example sine of minus 11 pi by 3. You could have looked at like this also, that it is minus 11 pi by 3 is what? It's like minus 3 pi plus minus 2 pi by 3, right? Or I could have written minus of 4 pi plus pi by 3 as well, right? This is what I could have written as well, right? minus 4 pi is minus 12 pi. So if this is what it was, right? My minus of 11 pi by 3, and I have added minus 4 pi plus, I mean I have not added anything, but I have just said that it would be minus 4 pi plus 11 pi by 3, which means that there will be one time I will come over here, second time also I will come over here, and then when I have come over there, I have to move from this side to this side, which is nothing but again it is in this quadrant I am moving in pi by 3 direction, and which is essentially what I have done over here as well. Similarly, here as well, minus 14 pi by 15 pi by 4, I could have written minus 4 pi plus pi by 4 as well, right? Which is nothing but again you go 1 pi, you come from here, second pi you come back again over here, and then you have to move in this direction pi by 4. So which is nothing but in this quadrant it is just pi by 4, which is the case as well, right? So this is what we were trying to do in this lecture. I think I have made it clear how to solve it. If you do not get it, please write in the comment section below so that I could answer your queries. Thank you so much.